Hi everyone, my name is Lukas. I work at the TUM and the DLR on measuring the sustainable development goals from space. And today we're going to talk about the very first one of them, which is no poverty, a goal that basically anyone in the world can agree to. And the question now is, in practice, how do we actually measure progress towards no poverty, especially in developing countries? And the answer to this is surveys. People in a lot of developing countries, the best information we have is people that go from door to door and sample representative households and ask them about their living conditions. This can, of course, not be done for everyone. So researchers have actually set out to use other more innovative sources of data that can tell us a bit about the living standards in regions where we don't have surveys or we currently have an outdated one or missing data, which is very frequent for these kinds of development indicators. So one thing that people have used in the past is nightlight activity to sort of proxy for human development. This can work very well, but especially you can see that kind of wherever a dense population is, we have lots of nightlight activity. But there's also one problem with this, basically that where there's no light, we don't really know anything about the living conditions of people. So one way to approach this is to use daytime images and combine this with machine learning, as in this paper by Gina et al. From Stanford. And they basically train a feature extractor on daytime images to recognize building structures, for example. So in the first column, this is a neuron filter that's trained on recognizing urban structures. And in the second column, we see something that recognizes something that resembles a forest or water structures in the third column, or roads in the fourth. So you can train a neural network to find these features and map the levels of poverty based on daytime images. There's, however, one problem with this, and I've brought a quote to underline this from David McKenzie, who's a lead economist at the World Bank. He's saying a lot of this work is using satellite data to try to predict poverty at a granular level for entire countries or continents. At the moment, such data seems useful for descriptive work, but it is unclear whether accuracy is enough to measure changes well over time. There may not be enough signal to be able to detect the impact of interventions. So, in plain text, can this approach also detect changes in poverty over time? Because this would be very useful. We set out to test this in Rwanda, and what you see here is basically, can we predict levels of poverty well? And we're looking for two things. We're looking for the points aligning, the colors of the points aligning with the colors of the districts. And also that these pictures on the left and the right align, especially that. And we see that if we only want to map the level of poverty in 1 year, this actually works pretty well. But now if we set out to do a change mapping, so kind of the differences over time in these local wealth indicators, we see on the left that based on nighttime light activity, we would think that wealth generally increases, especially around the center, around Kigali. Whereas this transfer learning strategy gives us a very scattered and not very consistent picture. If we look at this on the district level, this impression gets even stronger because we basically see down prediction for the southern province or Kigali city based on transfer learning. Nighttime lights, the alternative data source that we know to kind of work well for these tasks, predict a positive and significant increase in all provinces with different magnitudes, but it's always positive. And we have other data as well on poverty reduction in percentage points that ranges from 9 percentage points to 21 percentage points, but it's always positive and high. So there's a clear trend on the ground that this method does not seem to capture here. So what do we take away from this? Basically, two things. Poverty mapping from space works, and it can be very useful generally, which is very good news for a lot of applications. But also second, we may need further refinements of these methods so that they're able to spot changes well. This is an ongoing area of research, and there has been some progress made in the last couple of months, but with this method, this has made a lot of waves. From 2016, it does not work off the shelf. And this is something we should keep in mind for further research in this direction. Thanks a lot, and feel free to reach out if you have questions about this.